Hey, it's Mr. Estrada here, and in this video we are going to be working with tangents. So let's get to work. Okay, the first thing I want us to look at is the tangent-radius relationship. So to start, let's just briefly go over what a tangent is. A tangent is a line that intersects the circle in exactly one point. So AC or ABC is a tangent, and it's tangent to circle O at point B. Okay, and a radius is a line that connects the center of the circle and a point on the circle. So we could say that OB is a radius, assuming that point O is the center. Alright, so what does the theorem say? What's the tangent radius relationship? Well, the tangent radius relationship says if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. In other words, this tangent line here is perpendicular to the radius. So we know that this right over here is a 90-degree angle, because ABC is perpendicular to OB. Okay, let's look at an application of this. In the diagram below of triangle PAO, AP is tangent to circle O at point A, OB equals 7, and BP equals 18. What is the length of AP, and what is the measure of angle POA? Alright, let's begin with the first one. What is the length of AP? Well, here's what we know. This is what the tangent radius relationship says. It says that the tangent is perpendicular to the radius, so I know that angle A must be 90 degrees. And if angle A is 90 degrees, that means that this must be a right triangle. So the minute I see that I'm looking for a side, I'm looking for side AP, I'm going to take the liberty to label that X. And I know I'm working with a right triangle, I immediately think, okay, I can use the Pythagorean theorem to find the missing side. So that's what we use to find missing sides in a right triangle, the Pythagorean theorem. However, it feels like I only have one of the sides. You need two sides to be able to use Pythagorean theorem. PO is 25, right? Now, why did I say it feels like I only have one side? Well, because in reality, if you think about it, we know what OA is. OA is also a radius. And we know that the radius is 7, so since OA is also a radius, OA must also be 7. So let's go ahead and use the Pythagorean theorem. Remember, when you use the Pythagorean theorem, C represents the hypotenuse. So what's the hypotenuse over here? The hypotenuse, there's two ways to identify it. It's the longest side, and it's across from the 90-degree angle. So the hypotenuse is 25. So I have to make sure that when I plug in, the 25 has to be in the place of C. Okay, so let's go ahead and solve. I'm going to say x squared plus 7 squared equals 25 squared. So I get x squared plus 49 equals 25 squared, which is 625. Whoops. Sorry about the lag over here. So to solve for x, subtract 49 from both sides. 625 take away 49 is 576. X squared equals 576. Take the square root of 576 and we get x equals 24. So that means AP equals 24. The next question is, what is the measure of angle POA? Well, since we are given the measure of angle P over here is 44, and I'm looking for POA, I'm going to take the liberty and call that Y. We know that Y plus the 90 plus 44, what do they have to add up to? They have to add up to 180 degrees. So what does that make Y? Well, 90 plus 44, that's 134. Subtract it from 180, you get 46. Y is 46, which means that angle POA is 46 degrees. That's a 6, believe it or not. Okay, let's look at another theorem with these tangents. Tangents drawn from a common point. Alright, so here we have tangent AB and we have tangent AC. And they're both drawn from a common point. They're both drawn from the same point A. So the theorem says tangent segments to a circle from the same external point are congruent. In other words, if AB is tangent to circle O at B and AC is tangent to circle O at C, and they both have the same common point of A, then AB is congruent to AC. So AB is congruent to AC. So these two line segments are congruent. Let's look at an application of this now. In the accompanying diagram, PQ and PS are tangents drawn to circle O and chord OS is drawn. If the measure of angle P equals 40, what is the measure of angle PQS? So I'm looking for this angle over here. I'm going to go ahead and label that X. Okay, well, what do I know? I know that tangent lines drawn from a common point are congruent. So what that means is that PQ is congruent to PS. So I know this segment is congruent to this segment. How does that help me? Well, look closely. What kind of triangle is triangle PQS? Think about it. Let me highlight triangle PQS. Did you figure it out? Triangle PQS is isosceles because PQ is congruent to PS. So what that means is that these are base angles over here. And angle P is a vertex angle. So I can make this X as well, and then I can say X plus 40 should add up to 180, or I can just say 180 take away 40, I get 140, and then I can take 140 divided by 2. That's supposed to be a 2. This thing is lagging. I apologize for that. 140 divided by 2. And I get my answer. So what's 140 divided by 2? 70 degrees. So the measure of angle PQS is 70 degrees. Okay, I hope this video helps. Click on the link below if you're on my website so you can get some practice at the Regents Prep website. Take care.